Hi, so this is a quick video about ZP's Accelerator Platform. So the ZP Accelerator Platform is an integration between our screen printed electrodes, our capability of making biosensors, our electronics, our app development, our cloud platforms, and also our sort of data scientist team. So let me sort of start with this kind of holistic approach that we at Zimmer & Peacock have to electrochemical development and electrochemical in vitro diagnostic development. So we can start with a screen printed electrode. We're not confined to screen printed electrodes, but here we show the idea that there's a screen printed electrode. You can find these sort of readily available for purchase on our web store. Now you will find that in these two images we've actually put some microfluidic assemblies on top of these sensors. So one of them is a capillary and the other one is just a sort of well shape. So I'm talking about screen printed electrodes, but we could have made them by vapor deposition, we could have made them by MEMS fabrication. Now often we will go beyond just the electrode and then actually put some functional material on there. So it could be an ion selective electrode, it could be an enzyme based electrode, it could be an immunosensor type electrode. But we have electrodes or screen printed electrodes that we can turn them into biosensors. I suppose as I'm speaking I realize I just reach for one of these and give you a sense of scale. So this is the same sensor or screen printed electrode that's showing on the image at the moment. And then the next sort of part of all of this is, we expect the sample to kind of go onto here. Now if ZP is your development and manufacturing partner, we can also sort of put extra information around the screen printed electrode. So when you're making screen printed electrodes or you're making biosensors, you can have batch to batch variation, and so you have to kind of know about it, you have to calibrate for it, and so you can put information into things like QR codes. We can also do it with RFID, and you'll find YouTube videos and information on the web about ZP doing RFID tags as well. But screen printed electrodes, maybe some functionality to actually turn it into a biosensor and give it specificity, maybe a QR code to carry some of the calibration factors with it, and then it has to talk to some electronics. So if somebody's trying to rapidly develop a technology or rapidly get into a clinical setting, we have some off-the-shelf electronics. So for example, you can kind of take these kind of meters, you can put the electrode in there, kind of gives you a sense of actual scale. So we have screen printed electrodes, they can have microfluidics on them to help with sample. They can be functionalized to make them specific to the molecule or let's say pathogens of interest, depending on what you're looking for. Now we can also then do apps. So at ZP we have a very strong app development team. We program in iOS for obviously Apple devices, or Android for or also for Android devices as well. So now these apps are pretty useful because they make Bluetooth connection with our electronics, and so the app is the screenshot I'm showing here is just a simple app there. You can start the assay. Now what happens is because of smart devices now, actually we can make Bluetooth connection with the hardware. So the app tells the hardware what to do, and the hardware will then give the resulting file or data back to the app. And then on the app we can put an upload button. Now this is where it gets super interesting. So this ZP Accelerator Platform is really all about how can we very quickly get somebody from a screen printed electrode or a biosensor into a clinical or real world type application. Because I think one of the things that's wrong with biosensor development and development in general using screen printed electrodes, etc., is the time it takes to go from idea and lab work to real data. So to real testing. So we've obviously developed this kind of workflow where we can be part of that screen printed electrode and that biosensor. We have off-the-shelf hardware that just immediately works with the types of electrodes we make, and we have the apps, and the apps will talk to the device by Bluetooth, get the data back, and then there's an upload button here, and the upload button sends the data to something called Julie. Now Julie, you can Google Zimmer Peacock and Julie. It's got a slightly unusual spelling. It's D-J-U-L-I. It almost looks like it's spelled as the Julie, but Julie is a cloud database system for the acceptance. You can store electrochemical data in it, you can manipulate electrochemical data in it, you can share electrochemical data in it. So Julie is proprietary to Zimmer and Peacock. You can open an account on Julie, no issues. And from Julie we can send data out via an API, or you can get data out via a user login. Now the reason that we're doing this is we are imagining that you're somehow interacting with Zimmer and Peacock. I should say we're an ISO 13485 contract developer and manufacturer of electrochemical biosensors. So we're imagining that you're working with us, or you are working with us. We've helped with the sensor development. You now are going to go in and test these sensors in a real world setting. So you're going to need the hardware and the app, and then you're going to have an account on Julie, and the data is going to go to Julie. And this is kind of where it really gets modern and up to date, because as part of the development we will have come up with you a good electrochemical technique that will give us a lot of, not just it will give us rich data. So essentially what we're doing is we're analyzing the raw signal and looking for features that are particularly strongly correlated with the analyte or the pathology of interest. Now so we're essentially, we're using sort of data science and AI to really help with that extraction of signal. Now what we're expecting is you're a sort of an expert in your application, and so you might even have a third-party way of testing the sample. So let's say there's this clinical sample, and you're going to test it on a sensor, and by following our workflow it will go via the app to the cloud, and we're going to get the raw signal. Now that sample can also be tested by the by the clinical method. Now the clinical method could just be an assessment by a doctor. That's one kind of clinical assessment. It could be sent to a central laboratory where there's an ELISA assay, or LCMS, or a GC mass spec, or HPLC. But there's a way that's been already in use, and for whatever reason that way that's already in use is not necessarily fit for purpose, or maybe it's because you actually want to develop a low cost point of care device. But there's some way of sort of having a way of assessing the sample by the more traditional method, because what that means then is you've used our ZP Accelerator platform to test the sample by electrochemical testing, and then you've also been able to assess the sample by the sort of more traditional testing. For example, if it's an alkaloid in plants, you might have just used a HPLC to have measured it. Now what we're going to do is we're going to bring these two data streams together. We're going to bring the electrochemical signal together with the clinical or the analytical signal, and then that will allow us to essentially look at the biosensor value and the clinical value and make sure that they're really well correlated. But what it means is that we can we can look at that correlation and then look at the raw signal and say, is there a better way of extracting the signal? So this workflow is really good because it allows you to sort of do a sensor development, do an assay development, get it out of ZP and into the real world, where you and your clinicians or your, let's say, your field testers can start testing it. The raw data can go up to the cloud, and as long as we can then have a independent way of looking at the sample, we can start working on the correlation between the new test and the existing test and make sure they correlated correctly, and it allows us to go back and look at the raw data and say, no, can we do a better job of this calibration until we've got the kind of correlation that we're really looking for. So this is the ZP Accelerator Platform. And it leverages our expertise in electrode manufacturing, be it screen printing, vapor deposition, MEMS type fabrication. It leverages our ability to functionalize electrodes, enzymes, ionophores, immunosensors. It leverages the fact that we already have electronics and the app capability, and it also leverages the fact that we have this Julie database already in place. And so there's only, when you look at this workflow, there's just a few segments that are quite customized to each application, but there's a platform in which that customization can then sit, so you're not reinventing the wheel. I mean, to develop a system like this, just on your own essentially, I mean, there's millions of dollars worth of investment in this, but it really, the workflow we've created can really accelerate somebody's time to get to market. Anyway, I hope that was interesting, and if you've got any inquiries or questions regarding this, then please reach out to us at Zimmer & Peacock. Okay, thanks very much.